Hello student, I am Pankaj Singh welcoming all of you on this exam oriented and success related Drishti online platform. And this is the third episode of 100 important topics of geography for Prelims 2026. And in this third episode that I am going to discuss with first of all the question that I have given you in the second episode. And in the second episode some questions are there, and that is related to plate tectonics, divergent boundary, convergent boundary, formation of the Himalayas, formation of the Andes, and island arcs or volcanic island arcs. So let us see the question that we have to see. The question here it is. So with reference to the plate tectonics, plate tectonics, consider the following statement. And first statement, it says that plate tectonic, it explains the movement of the large rigid plate forming the Earth's lithosphere. So plate tectonic, it explains the movement of large rigid plates. So on this Earth's surface, there is a large rigid plates like continental plates, like oceanic plates. These are the rigid plates, and these are also considered in a lithosphere. It is actually a lithosphere, and the plates and plate and what I said that the lithosphere both are the same thing. So here is a large. It explains the movement of the large rigid plates forming the Earth's lithosphere. So here this statement is, we can say that correct regarding the plate tectonics. The movement of these plates occur over the semi-molten layer called asthenosphere. Yes, sir. These continental plates or oceanic plates, that is tectonic plates, are floating over the semi-molten below. There is what semi-molten asthenosphere is there, on which like the ship is moving over the ocean, the same way our plates are moving over the semi-molten asthenosphere. So this statement is also correct. And third statement that we are going to see, according to plate tectonics, convection current of magma and slab pull force only responsible for the plate movement. No, it is a convectional current of magma, that is correct one, but a slab pull is also correct one, but one more it is there, it is in a ridge push. So ridge push is not over there. That on the basis of that, this statement is what? Wrong. So only we can say that option A, 1 and 2 is correct. Thereafter, we are going to see the next one. It is about consider the following statement regarding divergent plate boundaries. Here, it has been given emphasis over the divergent plate boundaries. And in this one, the first statement is talking about divergent plate boundaries involve movement of plates away from each other. Yes, in the divergent, away from each other, this is the correct statement. And another, that new crust is created at divergent plate boundaries. If you go and see the second episode, in the second episode I have given clear cut information about that, how do the new ocean crust is forming along the divergent boundary. Yes, this is also correct. Divergent boundaries are commonly associated with the deep ocean trench. No, convergent boundaries are associated with the deep ocean trench. So this statement, again I say that this third statement is wrong, and 1 and 2 only is what? Correct. So next question, consider the what this question is already there. With reference to the convergent plate boundaries, consider the following statements. Convergent plate boundaries occur where two tectonic plates move towards each other. Yeah, that's true. And convergent boundaries are associated only with the volcanic activity, not with earthquake. No, I said that along the convergent boundary, magma forms, and there is a magma is causing volcanic eruption as well as, and it is also forming, I said that causing I said high intensity, high magnitude kind of earthquake. And you can be able to say that this is not, it is talking about only volcanic activity. So this is wrong one. This is what volcanic activity is happening, but not only volcanic activity. Along with the volcanic activity, earthquake is also occurring. So this statement is what? Wrong. And subduction commonly occurs when a denser oceanic plate moves beneath the continental plate. So one denser oceanic plate is moving over the below another continental plate or oceanic plate, then it happens. So yes, it is a subduction commonly occurs when a denser oceanic plate is moves beneath a continental, that is known as a subduction. So here it is I said that this statement is correct. So we can be able to say that option C, that is the 1 and 3 only is correct. Yeah, if it has been mentioned only, so ye wrong hota, because there is an ocean subduction is also taking place. That one denser oceanic plate is subducting below less denser, but it is not mentioned only, so therefore it is a correct one. So I say that this question, next point we are going to see, with reference to Andes mountain, consider the following statement. They were formed due to the subduction of Nazca plate beneath the South American plate. Yes, there's an you can go and see the what I said, that explanation how do the Andes mountain has been formed. That denser oceanic Nazca plate is converging with the South American continental plate, and it is subducting, and during that there is a formation of Andes mountain is going on, and they are associated with the volcanic activity. Yes, there will be volcano as well as earthquake will be there, so associated with the volcanic activity, that's true. And another one, they are example of ocean continental plate convergence. Yes, they are the example of ocean continental plate convergence. We can say that what option C, all three are correct. Is it okay? So thereafter, the next question that we are going to see, it is about consider the following statement. The Himalayas formed due to collision between Indian plate and Eurasian plate. Yes, Indian plate, or you can see Indian Gondwana plate, both are, you can be able to say it is enough. This statement is correct. And the formation of the Himalayas involved in volcanic activity? No. In the formation of the Himalayas, there is a continental convergence. During continental convergence, there is no formation of magma. But when there is an ocean continental and oceanic, when the one plate is subducting below, during that friction and the addition of water, release of pressure creates a magma, and that magma comes up and volcanic eruption. So during the continental, there is no volcanic activity is involved. And thereafter, the Himalayas are geologically young fold mountains. Yes, it is a young fold mountain. Like Andes is a young fold mountain, there is a Rocky is a young fold mountain, Alps is a young fold mountain, and similarly we can say that Himalaya is a young fold mountain. It is an alpine mountain system. So we can say that 1 and 3 is correct. Option A, 1 and 3 only. And now consider the following statement regarding island arcs. Island arcs are formed at the ocean convergent plate. That's true. Oceanic. When there is a Japan island arc, Aleutian island arc, there is a Philippines island arc, New Zealand, Indonesia, Andaman Nicobar. All these are formed by the what? Ocean convergence. All are formed by the. This is also known as the volcanic island arc also. So this is the correct one. They are consist of chains of volcanic island. Actually, there is in Japan and all. It is in a chain of volcanic islands are there actually. So this is what also correct. If you have any kind of doubt in this question, so please go and check it out. I said that second episode, it will be really helpful for you. And in this one, I have explained each and everything very clearly. They are commonly associated with the deep ocean trenches. Yes, they are also ocean that nearby the island arcs, like nearby Japan, there is an island, there is a Japan trench, nearby Philippines, Mariana, Mindanao trench are there. The Mariana is the deepest trench of the world, and thereafter we have been able to see there is a nearby Aleutian trench, nearby New Zealand. There is a Kermadec Tonga trench nearby. You can say like nearby Indonesia volcanic island arc. There is a Sunda trench or Java trench is there. These are the what commonly associated with that deep oceanic trenches as well as. So we can be able to say that option C, 1, 2 and 3 are what correct. So we are going to see that another in the third episodes of this 100 important topics for Prelims 2026 geography section. We are going to see it is about volcanism. That is an important topic is hotspot, the Pacific Ring of Fire, the intrusive landform and extrusive landform. In the Pacific Ring of Fire, it is very much second episode. It should be covered by you, because here it is an ocean continental and oceanic convergence is important for that. And intrusive and extrusive landforms we'll see. So let us go and see that volcanism and hotspot volcanism. So in this one, especially in the world, the two famous hotspots are there. One is in Hawaiian, another one you can say like it is a Reunion. And the first of all, let us go and see like if I am talking about if I am talking about like in case of, I say, there's an what there's an outer core and there's an what you can say like again let me, here it is an outer core, this is an what mantle, lower mantle, this is an upper mantle. What is happening actually along the outer core, there is an what very heat is there. Outer core has very heat, 4000 degrees Celsius around. In this region the temperature is around 4000 degrees Celsius, and because of the very high temperature, you can say, because of very high temperature, this is a 4000 degrees Celsius temperature, and in this region you can be able to say that and some radioactive minerals are there. These radioactive minerals has given the heat, and there is a formation of what magma, that is an especially basaltic magma, and this basaltic magma start moving upward, and it is very hot. This rising column of magma which is moving upward, it is known as a mantle plume. It is known as a mantle plume, and when it is able to reach near Earth's surface, then it is very hot enough, and very hot enough means it is known as a hot spot. We can say it is in a hot spot, and thereafter this hot spot, it is in a very hot enough, it can break oceanic plate or it can break a continental plate. So when it can break an oceanic plate, then it comes above the ocean surface, and then magma regularly come up, and then regular coming up of magma help in the formation of what a volcanic island. After that, what happened, this you can be able to say that this magma, yes, suppose there is an this is a plate is there, there is a plate, and this plate is moving over there this direction, and here if I talk about there is an you can say that ocean water is there. In this ocean water and below there is a hot spot exist like that, there is a hot spot is existing like that. So here if it is in a hot spot is there, and this is your mantle plume, this is your mantle plume, and there is a what hot spot. So what can happen, this hot spot will break the ocean plate, and it will start coming the magma in this region, slowly and slowly it will come above. After certain period times, what will happen, this it will start this plate is keep on moving. So this what I have said, that this volcanic island will shift to this region, and in this region you can be able to say like in this region there will be what again by the volcanic eruption new magma is there. So the first is this one, and the second it is formed this one. But after that, what will happen again, this hot spot is in a same position, this plate will keep on moving, and because of that there will be in a series of, this first will come over there, it will become second, and this one will become third, and there's a series of volcanic island can form. This kind of island, it is known as a Hawaiian island, and it is in a plates are keep on moving upward, and then series of volcanic island can be formed. This is, I said, that happening over the ocean surface. It is happening over the ocean surface, and you know that it is not happening along the plate margin like in the tectonic plates you have seen. There is a plate margins are there, continental, convergent, continental, oceanic, continental. Different boundaries are there where they are meeting. But in case of this one, that this hotspot is happening within the plate, intraplate. It is happening intraplate, and when it is coming over the ocean surface, there is a volcanic island like Hawaiian group of island. And now this third, if it is, this is the third one, now it is an active volcano. You can say it is an active volcano, but this island is what I said, that it become an inactive, or you can say that extinct volcano. Now in this one, no volcanic eruption will take place. Now the volcanic eruption which was taking place, which has been finished, and this plate will keep on moving, and you can be able to say hundreds of islands. Nearby, in the same way, Lakshadweep Island we have seen in our India, it has been formed, and because of the reunion hotspot, one, it is a reunion hotspot in India. When Indian Gondwana plate was moving over around, you can say that 70 to 100 million years ago, a reunion hotspot. The reunion hotspot has done the volcanic eruption and over the continent. And when it is over the continent, if it is taking place over the continent, So what will happen? The magma, this is in a continental part is there, and below the continental part there is a hot spot is existing, and this is in a, if I say that a reunion hotspot, and it is in a continental, it is in an Indian Gondwana plate or Indian plate. Over that, this magma has erupted out, and there is on the Earth's surface. It is forming volcanic mountain because it is a cold water. It solidifies very fast. It comes above, but over the ocean, over the continental plate, that it spreads, and due to spreading, I said that a reunion hotspot has created a water Deccan lava plateau. So the Deccan lava plateau has been formed by the water 70 to 100 million years ago by the reunion hotspot. So the two major hotspot, one it is a Hawaiian hotspot. So this is a Hawaiian island, you can say. Hawaiian island has been formed by this Hawaiian hotspot. So you can perhaps you are able to understand what is happening because of this hotspot. And now we are moving towards, I say that this question based on this, and let us see some statement regarding that. The hotspot volcanism refers to the volcanic activity caused by mantle plumes of the hot magma rising from the deep within the mantle. Yes, understood this statement? And it is independent of plate boundaries. There is no convergent, divergent. It is happening in the intraplate. As tectonic plates move over this stationary hotspot, it is an always it is a fixed. Remember that hotspot is always fixed. There is a chain of volcanoes are formed. The two classic examples are Hawaiian, and I say it is a reunion hotspots or reunion volcanoes island. So, and key features of this hotspot volcanic, it is occurs away from the plate boundaries. It is not happening along the plate boundaries. It is happening within the intraplate boundary. It is caused by mantle plumes, and it is rising from the deep mantle, produces sealed volcano. When it is magmas are coming up, and then it is over that it is coming, and it is over the volcanic island of what reunion it is forming. It is forming in a sealed volcano. It is forming in a sealed type, like armor sealed that we are taking in. So this kind of what magma comes, and they keep on spreading because it is liquid like. So it looks like shield. So Hawaiian has several sealed volcano also, sealed volcano type, and thereafter it forms volcanic island chains. Yes, it is very much clear to you. And as the plate moves over the hotspot, then volcanic island forms. Older volcanoes become inactive, means older volcanoes become extinct volcano or inactive volcano, you can be able to see. And then Mauna Loa in the Hawaiian is an important hotspot chains are there. And based on that, we can be able to see there is some questions are there that we have to answer for that in the comment box. Is it okay? So here, hotspot volcanism, consider the following. Hotspot volcanism occurs due to mantle plumes rising from the deep within the Earth's mantle. Again, hotspot volcanism occurs due to the mantle plumes rising from the deep mantle, within the Earth's mantle. Whether you have to see whether it is right or wrong. Second statement, it is always associated with the plate boundary interaction. Yes, you have to say whether it is right or wrong. Another, the Hawaiian Islands were formed due to hotspot volcanism. So you have to see whether how many statements are correct, and please answer that in the in the comment box, and I will answer it in the 4th episode. So here, that next topic that we are going to see, Pacific Ring of Fire. In the Pacific Ring of Fire, first of all, I say that Ring of Fire. Here, if I am talking about in this region, so what is happening? This is in a Pacific Ocean. This is in a Pacific Ocean. In this Pacific Ocean, if you can say, there is a Juan de Fuca plate. One Juan, you can say like there is a Juan de. You can say that Juan de Fuca plate, oceanic plate, and here you can say that this is your North American continental plate. This is our North American continental plate. So here it is going on this subduction. There it is this is an oceanic, and this is what you can say that continental. So during oceanic continental plate, it is going on, subduction is going on along this North America. There is also one Cocos plate is there. and here it is moving, it is this one, and there is an also oceanic, and this is in a continental, this is Central American part. And here you can say that there is a Nazca plate is there. There is a Nazca oceanic plate is there. Nazca oceanic plate, and this is all are oceanic. It is moving this side, and the South American plate is moving this side. And along with that, this denser oceanic plate is subducting, and there is a volcanism. And then when it is going on, there is a formation of magma, and volcanic activity is going on by the ocean all along this. There is a country of Chile. There is a country of Peru. These are the different countries are there. There is a country of Central America region, and there is a Mexico and all. There is a USA, Canada. This region it will be. I said that ocean continental convergence is going on, and in this one you can say that volcanism is taking place. And also when this is going on, there is a greatest earthquake, high magnitude earthquake also occur. And now there it is. This one is here that the Pacific plate is moving on the, this is happening, what I am talking about, this one on the, this one I am talking about the on the Eastern Pacific. What is happening on the Eastern Pacific? On the Eastern Pacific, there is an ocean continental convergence is going on. And now we are going to see on the Western Pacific, and in the Western Pacific we can be able to say there is a there is a Pacific oceanic plate. There is a Pacific oceanic plate, and this Pacific oceanic plate here, what is happening? That this side and here you can see that it is in a Eurasian. This section of what I said, that it is in a Eurasian. It is an Eurasian continental, and this part, these are Eurasian oceanic. So here it is an oceanic convergence. In this region you can say oceanic convergence is going on. There is an oceanic, and during the oceanic convergence, what is happening? There is an island arcs. When it is a ocean plate is going, formation of magma, and then island like Japan Island parallel to this Japan trench. So there is a formation of Japan Island is there. There is a parallel to this Japan trench, and there is an Aleutian Island arc. There is a group of Aleutian, Japan trench, Kurile, Philippines parallel to this Mariana and Mindanao trench, and there is a New Zealand and parallel to this Kermadec trench and Tonga. So in this region, when the plate is going downward, there is I said that again magma formation causes what magma is coming up, forming a chain of volcanic island. And when it is forming a chain of volcanic island, at that volcanic eruption is taking place, and also earthquake. So in this is considered as, here this side is also full of volcanic eruption and earthquake. This side is full of volcanic eruption and earthquake. So this is a Pacific ring of fire. So we can say that in this region 75% around 75 to 80% or more, there is a volcanic activity, and around 90% earthquake occur. This side ocean, this side ocean continental. This is a Pacific ring of fire, and it is in a horseshoe shape structure. And which are the country lying along this? What we can say, the Chile, there is in a Peru. These are the countries are there in Mexico, and there is in other countries, Central American, Mexico, and then USA, and then there is in a Canada this side. And here you can say Aleutian, Japan, you can say that Philippines, there is in a Indonesia, this side is New Zealand. All these are part of what this Pacific ring of fire. And here we can say that in the Pacific ring of fire is a major zone of what intense volcanic and earthquake activity. Surrounding the Pacific Ocean, it forms a horseshoe shaped belt. 75% of the world's volcanoes and 80 to 90% of the world's earthquake occur. In the Pacific ring of fire encircles the Pacific Ocean and passes through many countries like Chile, Peru, you have seen in the South America, and Mexico in the North America, Japan, you have seen. This side it is in what in this region ocean continental convergence is going on, and there is Japan, Philippines, Indonesia, New Zealand, and this side it is in you can say that ocean convergence is going on, and Japan Island, Philippines Island, Indonesian island group, volcanic island, and New Zealand all. So these are formed in this region. And here that formation of tectonic Pacific ring of fire, the ring of fire is mainly formed due to the subduction zone. Yes, it is mainly formed by the subduction of the plates, where one tectonic plate moves beneath the other. Important tectonic plates on the eastern Pacific, what we can say that ocean continental, where it is in a South America and North America, ocean continental. Nazca plate subducting below South American continental plate. O means oceanic, C4 continental. And then Juan de Fuca oceanic plate is subducting below North American, what you can say that continental plate. This is on the eastern, and there is a volcanic eruption, and there is a earthquakes, and there is an Andes formation, Rockies formation. This side we can say on the western Pacific there is an ocean convergence, and in this one Pacific oceanic plate which is subducting below Eurasian plate, and there is an also Pacific plate is subducting below Eurasian, you can say that Indo-Australian plate also. In this region, when the collide, the magma rises, forming volcano and causing earthquake and volcanic island arc. So many things are happening. You can say that major feature kya hai? What is the major? Volcanic activity 75% or more than that around. Earthquake around 90% here. Deep ocean trenches are also associated. When the one plate is subducting, always there will be nearby South America. There is a longest Peru-Chile trench exists, and everywhere trenches exist. Mariana Trench, it is nearby Philippines island arc. The trenches are also existing, and Mariana Trench, deepest trench, it is in a 11003 meter of the world nearby Philippines island arc. And the Philippines when the Philippines has been formed at that time, there is trenches are also existing nearby, and Peru-Chile trench is 6100 kilometer long. And major source of the earthquakes, volcanic eruptions, tectonic, and sometimes the plate it is going on, then sometimes the plate rebound back, and the upper plates rebound back, and there is upliftment of large amount of plate water, and that water uplifted convert into tsunami. This way, and the horseshoe shaped belt, this Pacific ring of fire, and about 40,000 kilometer length, you can say that, and subduction of tectonic plates in the Pacific ring of fire, one side ocean continental and side oceanic. And then let us see the question based on that. You have to answer it, and I will answer this question in the in the next episode, 4th episode. It is in a horseshoe shaped belt of volcanic and seismic activity surrounding Pacific Ocean. We have to say whether it is right or wrong. And more than 70% of the world's second statement, more than 70% of the world's active volcanoes are located in this region. That we have to say whether it is right or wrong. I'll give in the answer in the next episode. The region is mainly associated with the subduction zone involving the Pacific plate and the surrounding plates. We have to say that whether it is wrong, and I'll answer about it whether in the right or wrong in the next episode. So please answer answer this question in the comment box. So here the next one that we are going to see, it is about intrusive and extrusive landform. In the intrusive, we can be able to say there is if I am talking about in the case of intrusive, intrusive volcanic landform. So suppose there is if I am talking about there is an earth surface is there. If I am saying that there is an earth surface is there, if there is an we can say that earth surface is here, and below the earth surface there can be, this is our this is an earth surface, and you know that there's you can say like there's granitic magmas are there, granitic magmas, especially if I talk about granitic magma is below the earth surface, and that they take a million, they started below the earth surface. If it is bound below the earth surface and it is taking million years to solidify, and they takes a million years to solidify. I said that below the earth surface solidify, it takes million years. The magma is below the earth surface. Suppose there is a magma is there, and here it is in a magma, and this temperature is 1100, and outside temperature you can say that 1000 degrees Celsius. So only the temperature difference is what you can say 100 degree. So very less temperature difference. So when there is a temperature difference is very less, it takes it cools and solidify very slowly, and it takes million years. And during the, just you think for yourself also, just think that if one is in a molten iron, another is another is in a molten iron. So one molten iron, it is in a molten form, another. So one molten iron, you are what I said that cooling slowly and solidifying slowly, and another it is I said that cooling fast and solidifying fast. So those who are cooling, it will be stronger or slowly or fast. Which one will be stronger? So those who are slow, you know that it is in a slow, there is an intermolecular bonding of different minerals will take place, crystal formation will be there, and it will be the strongest, and it takes a, or inside this rock there is a formation of minerals also take place. So those who are slow cooling, there is a grain, coarser grain crystal structure in this region. In this, what you can say that there will be a crystal structure will form, or you can say that coarse grain. And that this magma which is remain below there, and it is in a very viscous, it is in a, what I can say that highly viscous magma. Highly viscous means it is in a pasty, and it slowly solidify. And this kind of, what I said that this kind of solidified magma below the earth surface, it is we can say that intrusive, you can say that intrusive landform or intrusive volcanic landform. So this is kind of what you can be able to say that it is in a kind of what batholith. It is known as a, you can say that it is considered in a what batholith. The very hard and a very large amount, and if by eroding it, by eroding the upper surface, you can see the top of it, and it cannot be below, and it is in a source of minerals, iron ore, different kind of things. If there is in a batholith, if the same way, if it is, I said that a smaller feature is there, if some smaller feature is there, and it is in a upward, it is in a uplifted in the convex shape, or you can say that upward uplifted in the this convex shape, it is upward uplifted in this form, a convex shape, or convex or mushroom. It is known as, I said that laccolith. It is known as a laccolith. And if it is, I said that there is some kind of vertical structure is there, it is in some kind of vertical structure, and something like that, or up, you can say that how can you remember, suppose this is in a bike, और दिस इज इन अ बाइक, और बाइक को यदि आप रोड पे चला रहे हो, बेटर है कि आप हवा में चलाओ। बाइक को किधर चलाओ? You should make the bike to run like this. If you are making the bike to run like this, so it will be, yes, you become a hero, macho and all. So macho, you are becoming macho because of that. Just I'm making to remember bike. And when the magma solidifies like this, so bike is running like that, and dike. This is what I said that the magma solidify in this form. It is known as a dike, or you can say that dike or dyke. And there is a what when the magma solidify horizontally, it is known as what sill. It is known as a what sill. When the magma solidify horizontally, it is known as a sill. And granitic magma solidify, and when it is in a saucer shape structure, it is in a solidification, it is known as our lap is like a what a saucer shape. Lap kaisa hota? Lap is a saucer shape. So you can remember saucer or bowl shape. So when the magma solidify in this form, it is known as a lopolith. And I was trying to make it to remember lap. Lapolith, you can say lopolith. And there's a convex shape, this one mushroom like, and this is an easily seal fish is lying on the row on the what the floor like this. Seal fish is lying on the what flat. So seal, it you can remember like this. When the magma solidified like this one, it is known as a dike. And bathroom, what kind of bathroom you want to, what I said that take bath in, you want a large bathroom, yes or not? So you can be able to say that this is a large shape of structure, this is known as a bath for batholith. This way you can be able to see here that yes, intrusive landforms, if I am talking about intrusive lands, are formed when magma cools and solidify below the earth's surface without reaching the earth's surface. If it is not able to reach the earth's surface, so formed inside the crust, cooling is slow, producing coarse grain, means crystal or coarse grain, and usually exposed after erosion of the upper layer. When the erosion upper layer has, then you can be able to see this one. And the major types, we can say that batholith is there, very large igneous rock. The magma is solidifying, it is forming a igneous rock. There is a granitic. Igneous rocks are two types, granitic and basaltic. And here very large igneous rock body batholith that we have seen, very large. Laccolith, you have seen that is in a convex or mushroom shaped intrusion that pushes the rock layers upward. Lopolith is in a saucer shape. Lap, I have said, lopolith is in a saucer shape. And dike, you can say, or dike, both when it is written, it is in a vertical wall like magma intrusion cutting across the rock layers, you can see. And seal is in a horizontal magma intrusion, what I said, that between the layers of the rocks. It is okay. This is about the intrusive landform or intrusive volcanic landform. You can let us see the question based on intrusive igneous landform or volcanic landform also, you can say. So that with reference to intrusive igneous landform, consider the following statements. First statement, they are formed when magma solidify below the earth's surface. Second statement, you have to answer it. I'll answer all this question in the next, I said, that episode. So please, everyone, requesting answer all this question and in the comment box. Dikes are what I said, that horizontal intrusion that form the parallel to the existing rocks layers. And the third statement, cooling of magma in intrusive landform is generally slow. And what I said, that generally slow, and there's a course gradient. So you have to see whether it is in a right or wrong. In the next episode, you can see all the answers. And the next one we are going to see, it is in about extrusive landforms. And here it is, we have to see like if I talk about like extrusive, if I'm talking about extrusive volcanic landform. So extrusive means it is forming on the earth's surface. Extrusive means we can say that it is forming over the earth's surface. And here, if it is, I'm talking about, yes, so this is the earth's surface is there, and this is your earth surface is there. And when the magmas are able to come onto the earth's surface, if it is, you can say that when it is able to come onto the earth's surface, then it is forming in a different kind of, what I said, that volcanic cones. It forms different kind of, what you can say, that volcanic cones. This is known as volcanic cone. And please go and read about cinder type of cone. Cinder type of cone. In this class we cannot be able to, this is in a volcanic cone itself, and here we can be able to say there is some kind of composite or stratovolcano is also there. There is a parasitic is also there, and there is a lava dome. And I will show you in this one, because I am going to teach also lava, the different kind of structure in the conical shape volcanic mountain it is coming. And then world volcanic mountain, large, highest volcanic mountain of the world, it is, you know, that it is South America along the Andes. There is an Ojos del Salado, there is a Cotopaxi, Chimborazo, different kind of volcanic mountains are there. Here you can say that these are the volcanic cone can be formed. So now the next part that we are going to see, it is about here we can say like in this one, so on the earth's surface they can be formed like that. So one volcanic cone, you can say, and thereafter, yes, the top of this volcanic cone, there is a saucer shape structure. This is the main vent pipe. This is the main vent pipe through which magma comes. And this structure is known as a crater. So we have been able to say that crater, what is crater, we have been able to say this is a saucer shaped structure at the top of the mouth of the volcanic mountain. It is known as a crater. And here after that we can be able to see like and the next part here I am going to see on the earth's surface, you know that when the magma, another one I'm going to teach you the caldera. And the caldera, you know that caldera, in case of caldera, what is important part is there that first of all, magma, when the magma forms below the earth's surface, it started moving upward, and then just near to the earth's surface they start filling in a particular region, and that is known as a magma chamber. They started filling all this region, that is known as a magma chamber. And after, when the magma chamber has been filled up, then the volcanic eruption take place, and there's a formation of what a volcanic mountain keeps on happening. And after there is a volcanic eruption is going on, you know that thereafter, when this has been pressurized, magma comes out, then upper portion of the magma chamber become little what, empty. The magma which has come out, and then the magma chamber little get empty. And after that, in this region, magma does not come for longer period, then what can happen, that this volcanic mountain, and there is a below empty surface. Over this below empty surface, this volcanic mountain you are watching, it can, under the gravity, can collapse down. And when it collapse over there, because it is an empty surface, and you can be able to see, like I say, that there is a collapse is taking place, and because of the collapse, there's a very large, you can say, that saucer shape structure come into, and in this one water accumulate, and this is what it become a caldera. Caldera is forming when when you can say that a large volcanic mountain, when a large volcanic mountain is what collapsing down over the empty or partially empty magma chamber. So this way it is collapsing down, and the caldera is forming, and a part of it, there is an also formation of what there is an also sometimes you can say, like on the earth's plate, there is an also some formation of when the magma is coming up from the below. Like I said, that hotspot magma, when it is coming on the earth's surface, and there is a formation of lava, and you can say like Deccan lava plateau. So lava plateau can also form. So there is a formation of lava plateau. So there can be a formation of what I said, that lava plateau on the earth's surface, when the layer of lava comes, and which lava? Hotspot lava. I have explained it earlier little. So where it is, and I said that this way it is coming magma. Another, it is, I'm talking about extrusive, which is happening on the earth's surface. And another point we can be able to see, like we can be able to say the same way, if it is in an earth's surface, and if it is in an earth's surface, and magma is forming, granitic magma, it is in a very dense granitic magma is forming just near to the earth's surface. It is in a granitic magma which is forming just near to the earth's surface. What will happen? It can, what I said, that explode, and this easily it can come up and started when the very dense like halwa like magma, when it is forming just near to the earth's surface, it easily break the earth's surface, and it is coming up, and it is making near to the earth's surface, just near to earth surface. And then it is easily come up without any pressure, and it is making in a dome shape. What I said, that dome shape lava. So it is known as a lava dome. So these are the things which is forming. And one thing here, its temperature is suppose 1100. Its temperature is suppose, I am talking about the magma which is on the earth's surface. Its temperature, it is suppose 1100. Outside temperature is 25. So on the earth's surface, when the magma is coming, then the temperature is suppose 1100, outside is 25. There's a large difference in the temperature, and then it cools very fast. It you can say that cools very fast, and when it cools very fast, they are not able to make a crystal structure because of cooling very fast, and it has a powder like grain. So it is in a a finer grain can be there. It is in a when during the solidification, fast cooling, you can say fast cooling and solidification, and due to that there will be a finer grain like lava plateau, Deccan lava plateau. Like if I say that Deccan lava plateau which solidify very fast, so after breaking it forms in a black clay soil. Clay is a very finer particle, so therefore it is forming in a clay soil. And here we can see, like in this region, extrusive on the surface, extrusive landforms are formed when magma reaches the Earth's surface as lava and solidify. Formed on the anything below the Earth's surface is known as magma. On the Earth's surface, same thing, molten, it is coming known as lava. And here it is known as a formed on the Earth's surface. It is that's extrusive landform. Its cooling is rapid and therefore producing fine-grained rocks, often associated with the volcanic eruption. And there's some volcanic cones are there. Yes, we have seen some volcanic cones will be there. Cone-shaped mountains, lava plateau formed by the repeated lava flows layer by layer. There's a Deccan lava plateau can form. Volcanic craters on the top of the volcanic mountain. There is a saucer-shaped structure, bowl-shaped structure, depression at the top of the volcano. And caldera, large volcanic depression formed. It is when the volcanic mountain has been collapsed over the empty magma chamber. There is a large volcanic saucer-shaped structure, large volcanic depression formed after the eruption and collapse. It is caldera. And the lava dome-shaped structure formed by the viscous lava, varied viscous lava granitic, and it is coming up, then easily it spread and dome structure forms. So we have been able to see on the basis of that, with reference to the extrusive igneous landform, consider the following statement. That first statement, they are formed when lava erupts into the Earth's surface and solidifies. This is the statement we have to say whether it is right or wrong. Rapid cooling of lava usually forms fine-grained igneous rock. And another one we have seen, there is what lava plateaus are generally formed by the successive flow of highly fluid basaltic lava. So please, what I said, that check out all this question, and in the next 4th episode I will answer all these questions. So please, I said that answer, and if you have any doubt, put your question also. I'll try my best to what I solve those doubts in the coming classes, so coming episodes. So it is please do comment and like this video, and come on this platform where it is I said that which is a success oriented and exam oriented. So we'll meet in the next episode, the 4th episode. Till then,
for more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.